All right, here we are again with another hypothesis test for one proportion. Kind of a different format here, so I kind of wanted to run through this. Test the claim that the proportion of people who own cats is significantly different than 10% at the 0.01 significance level. So from this here, we get a couple of things. Our proportion, 10%. From that, we can get Q. Remember, Q is 1 minus P. And this, for now, is the P from our claim here. And we also have here an alpha, and I'm going to just write it here since it showed up at this point, 0.01. Now, our null hypothesis is going to be that P is equal to 0.10. And then our alternate, it says significantly different than 10%. So when we have significantly different, what we have here is it's just not equal to. And so I'm going to do an equal sign and then a little line here for my not equals, 0.10. You could also say P is not equal to 0.10, but you see how much more writing that is. But essentially with that equal sign and the line there, I'm kind of negating it. Don't have a good not equal to that's easy to find here. So if it's not equal to, a little bit new and interesting here, this is a two-tailed test. So we've got a two-tailed test. And then we can kind of answer these first things. And we have some drop-down menus here. So again, we have to choose the right thing. This is a proportion is equal to, and here we have some options. Choosing the one that makes the most sense here. And then again, our proportion here. Now we are different than, so that's just not equal to. And again, the same one. These values should be the same here. We change this. The first one's going to be equals. This is, depending on what we have, but it's different than. And so here, choosing two-tailed. Now, got the null and alternate hypothesis. Based on a sample of 200 people, 4% owned cats. So I've got n is equal to 200. And then I have a p-hat here of 4%. Now, don't want to make the 0.4 mistake, but it happens. So from this, I need to use the information I have here to find my standard error. Again, the standard error for a proportion is P times Q divided by N. And there's our deal. A little bit of work for you here. Now again, I like to find my test statistic here. I'll call it my test stat. Again, we take an equal sign. And we have P hat. We subtract P. And we divide by our standard error. And again, I'm letting Excel do kind of all the rounding here, all the arithmetic, the work there. Okay, not sure what I did there. So, now, my picture. I've got a distribution and it's normal. My test statistic is somewhere over here, negative 2.8 stuff. Now, this is a two-tailed test, which is new to us. So we actually have this error range. We got to find the tail. Since it's a negative value, we find the left tail. If we had a positive test statistic, we'd find the right tail. And then we're going to double it because we have a two-tailed test. So again, the picture here, we're going to have it two-tailed, which we can kind of think of. I guess I could add it here. This is what my error looks like. But really, in my mind here, what I'm going to do is double this left tail in my mind and in Excel here. So I'm going to do 2 times. The left tail is nice. It plays nice with us here. We can use a normal standard distribution. Pop in my test statistic. And again, just let Excel do the work. Hit true. So again, we doubled it because we were two-tailed. And then we have to be clever here. If we have a positive test statistic, we have to find the area to the right of it and then double it. If we have a negative test statistic, we'll find the area to the left and put that in here. So the p-value in this case, 0.0046 followed by an 8, so that 6 is going to round up. And then we make a comparison here, our p-value comparing it to our alpha. So our p-value is less than our alpha. So we reject the null hypothesis. If we reject the null hypothesis, then there is enough evidence. If we were doing that last one, there is enough evidence at the 0.01 significance level to conclude that. And then we go with the alternate hypothesis, that the proportion of people who own cats is significantly different than 10%. So we didn't have all of that here, so we got this. Boom. Oh, it's always nice when it works out. Okay, let's see. Some of these actually have it here. Okay, so here we have one that actually has kind of the last step. Again, a presidential poll. Research suggests that less than 46% of Americans support the Republican presidential candidate. They claim... Well, we'll see how far we get on this. Maybe. So, P is 0.46. They get 1,000 responses. So we have 1,000 in. Oops. Probably want to do Q here. I've been doing that, so might as well. And then N is 1,000. Of those who responded, 448 of them said they support the Republican president, so we'll call those successes in terms of this. This is 448. And notice here we have a little bit of work to do to find our p-hat. So this is this guy divided by this guy. And that's how we found our p-hat, taking the number of successes, dividing by the number of trials. Select the correct null and alternate hypothesis. So again, we have a proportion here, and I think it said that less than 46%. So we want it to go here, and we are left-tailed. I am skipping out on a couple of the steps because I'm trying to get all this done in less than 10 minutes. P times Q divided by N. And the square root of that, forgot to say that. So then we get a test stat, always important. It is going to be p-hat minus p divided by our standard error. And our sweet little image. We are left-tailed here, so here's 0, negative 0.76. Oops. So it's going to be something like this for our p-value. So since it is left, we can do a normal standard distribution, click on our test statistic, and hit true. And I don't know if we were given an alpha. Nope, here comes alpha. So 0.2232. Decide whether or not to reject the null hypothesis at the alpha equals 0.05 level. So again, we are greater than alpha, so we do not reject. We fail to reject the null hypothesis. And if we fail to reject, then there is not enough evidence. And there we go. So rush through a little bit, but another example. Let me know if you have any questions.